Good afternoon, YouTube. How's everybody out there doing? I think we have 67 days until the first testing day, until the first SHSAT of 2019. So, you guys are not studying yet. It's a good time to do it before school starts, and you have all the competition between your normal classes and normal exams, and trying to do this one. Kind of wish they would do the SHSAT over the summer, but that's the way these things go. So I'm going to continue on with this as lightning round. So we're going to do maybe 1, 2, maybe 3 problems today in about 15 or 20 minutes, I hope. Sometimes we go to 40, 45 minutes on these kind of things because we explore a lot. So again, this applies to both SHSAT 8, SHSAT 9, and I'm going to stick with some word problems again today. Just let me get my screen right. All right, that's our first problem. It should be showing on your screens by now. Give me 1 second. It's not showing on my YouTube sample screen. I don't know. There must be a long delay here. All right, there we go. All right, so there's a frame maker who can make rectangular frames or triangular frames. A customer wants to order 10 frames of either configuration. The frame maker counts 35 side pieces. All side pieces are of equal length. Can he make 10 frames with no leftover pieces? All right, so we have a side piece, and we want to put 4 of them together to make, it's going to be rectangular frames. So in this case, it's obviously going to be a square, because they're all of equal length. Remember, a square is a rectangle, and a triangular one. And the customer's aware of this. All side pieces are of equal length. So this is a square, and this is an equilateral triangle. Okay, so that we're okay on those sides of things. So frame maker can make both of these. Okay, using that. Okay, a customer wants to order 10 frames of either configuration. So the customer's not saying how many. They're just like, give me 10 of them. Okay, and the frame maker's like, I have 35 side pieces. I'm not sure if I can do it. So he needs a way to calculate whether that's possible or not. All right, so that's the premise of the problem. So how would you go about to do this? So as in usual, you can pause the video at this point if you're catching this on the replay, and try to figure it out yourself. This is one of those problems that are done through simultaneous equations. So we know that the total number of frames is going to be 10. So we're going to have triangular frames plus rectangular frames is 10. All right? That's an equal sign. And we're going to now do a thing based on, so there's 3 for each triangle, plus 4 for each rectangle, and that's going to be 35 pieces, because it's the end of the day or something, and that's all he has left. All right. So the question is, now these are our 2 equations. What can we do with them? Well, one thing, first of all, you have to get this set up like this. And the way I like to think of this, if these were dimes and quarters, you'd have 10 cents for a dime and 25% for a quarter equals some dollar amount over here. So I just like to set them all up like this, so that its triangle has 3 sides, just like a dime is worth 10 cents, and a quarter is worth 25 cents, or a rectangle has 4 sides. And the total amount is always the total amount over here, including up here. So the question is, how can we use these two things to work with each other to give us the number we want, or numbers we want? So there's 2 ways to do this. One is to substitute for t or r in here, and the other is to add or subtract these 2 equations. Okay, so let's try both ways. So if t plus r is 10, then therefore t equals 10 minus r. Okay, all I did was subtract r from both sides, and I got t equals 10 minus r. Now that we know what t is, we can come over here and substitute it. Okay, so we have 3 times 10 minus r. We have to maintain the integrity of this. That's why I put parentheses in here. We can't do 3 times 10 minus r, then we get 30 minus r. That's wrong, okay? So we want 30 minus 3r. And then we're going to drop down the rest of what we had, plus 4r, plus, equals 35. All right, let me just make sure I have the screen set up right for you guys, and that everything's going in the right places here. Yeah, we seem okay. And then we're just going to solve it. We have 30, we have minus 3r plus 4r, so it's plus r equals 35. We subtract 30 from both sides, and we get r equals 5, okay? If r equals 5, we can feed it back into the first equation here. So we have 5 plus r equals 10. Obviously, r is also 5. So if they're both 5, does that match here? We get 15 plus 20 is 35. So yes, that does work. So the answer in this question, SHSAT question is not just going to be a true or false one like this, although there may depend. For instance, if this is a grid in, you may have to grid in what r was, like 5, or grid in what t was, which is also 5. They could also say grid in 1 for true and 0 for false or something like that. So we're going to show the other way now. Let me write the 2 equations again. So we had t plus r equals 10, and we also had 3t plus 4r equals 35. So our goal with these 2 equations at this point, we're not going to do the substitution way. We're going to either add or subtract these 2 equations. So the goal is to cancel out a t or cancel out an r. Okay? So we can do either one. All right? So I'm gonna just multiply the top by 3 everywhere. So what I do to the left side, I do the right side. So we're going to get 3t plus 3r equals 30. So now we have these 2 equations. And if I subtract them, 3t minus t is 0, 4r minus 3r is r, and 35 minus 30 is 5. So we get the same answer that way. And this would have worked if we substituted for r as well. Okay? In fact, let's do that just to show you guys. So if we want to get rid of r, if we had the t plus r equals 10 again, and the 3t plus 4r equals 35, if we want to get rid of r, we would multiply the top by 4. So we get 4t plus 4r equals 40. And now if we subtract the t's, we get 1t plus this cancels out equals 40 minus 35 is 5. So we get r as 5 and t as 5. Those are the 2 numbers we were shooting for. All right? So this is a classic kind of SHSAT question. It's most likely going to be in the SHSAT of some shape or form, both in the grade 8 one and in the grade 9 one. And for all we know, it might be the same exact question on both. That said, be aware there's about, I believe the number is 18 different versions of the SHSAT that's produced each year. There's not a lot of transparency in the SHSAT and how they do it. So we don't know if they're just juggling the order of the question numbers or what. But it's my understanding there's maybe some commonality across these different 18 forms of the SHSAT each year. This way you can't cheat and so on. It's the same question. All right. So so whether the question is exactly the same or not is up for grabs. All right. So this is solving the simultaneous equations, and as far as I'm concerned, it's probably mostly a grade 9 question, but this can also be brute forced just by observation, and especially if they give you A, B, C, D, you can take those answers and feed them back into the question, all right, to double check it. And again, you're going to feed whatever answer you get by solving this with the simultaneous equations or through the substitution form in the beginning. You're going to feed it back into both equations and see if it works, and then make logical sense of it. When you have the 5 and the 5, you know, if you ended up getting 500 and 500, and you're only making 35 frames, you have to have the mathematical astuteness and the number sense to know that your answer is just in left field. Okay, so we can't always throw that out. You still have to have some sort of estimation going on in your head about what the answer should look like. Okay, all right. Okay, so that's that question. Let's see, how much time do we use there? We used 10 minutes, so let me try another one. All right, let me make sure this just came up on you guys' screen. What I might do on the lightning round tomorrow is do another one of these simultaneous equations where the simultaneous equation actually doesn't solve the problem. And there's more you need to do even once you set that up. There's some common questions that come up based on that. All right? Okay, so I believe the question is now popped on your guys' screen. By the way, I'm Greg from Greg's Tutoring at GregsTutoringNYC at gmail.com. I tutor a lot of specialized tests, including the SHSAT. It's a lot of fun, a lot of smart kids, and a lot of good, intelligent, intellectual conversations, and a lot of this go back and forth between myself and my students. So please feel free to contact me about any questions about the whole process of registration, questions about specialized high schools, and obviously I do tutoring, one-on-one tutoring, and I also do group tutoring. Again, there's only about 9 weeks left, and it's time to resolve some of these things. All right, so the next question is kind of in an awkward form, and I did that on purpose when I wrote the question up. And it almost looks backwards because it is. So let's visit the narrative. So Joe's 2019 net income will be $100,000 after a bonus and a raise totaling 15%. If the bonus is 15% of this net income, how much will his raise be? Okay, because what I did was I modified this because normally your bonus is based on your income in some way. Maybe it might be 15% as well. I'm telling you guys after his salary is figured out. It just so happens that they figured out that his bonus was 15%. Okay, and maybe and once you know the algorithms, you can set it up so that would work out that way anyway. Okay, so let's go through it again. So Joe's net income will be $100,000 after he gets a bonus and after he gets a raise, a 15% raise. So now that we know his income is $100,000, if the bonus is 15% of the net income, how much will his raise be? All right. So let's try to map some of this into English. So $100,000 is what he ends up with. All right. His bonus is 15% of that. Right. So it's 15% of this. That's his bonus. So we can do two things when normally in a lot of problems, when you hit percentages, you can either use the raw number, like the 15%, and either add or subtract it to something, or you're looking for something like 1.15%, where you add or subtract the percentage to 1, or you're subtracting it, where you're actually looking at 0.85%. So you have to decide on a problem like this, which of these three scenarios you're going to use. Okay? And in the last one, it's normally straight up whatever the number is. In the first one, you're going to figure out what it is and add it back into something. In this case, not this number, because that's the final number. And in something like here, you might also add and subtract it. So you have to be aware of some of these percentage problems. You learn percentages technically a couple of years ago, and you've been seeing them in stores basically since you've been born. You really have to hit home what is this thing talking about. So just to be clear, what I'm talking about, for instance, if something is $100 and it's 40% off, then you could take $40 off of that and end up with $60. Or you can start out by saying if it's 40% off, then the price is going to be 60% of the price, or 60. So either way, you end up with 60. And sometimes the numbers work one way or the other. You can get, if you have an ugly multiplication, you may want to do the 40% and do the subtraction. And if the multiplication or something is not too bad, you just may want to do it straight up. Okay? And then it could, and that was a discount. It could be a price increase. So if a price increase of 40%, you could add 40%, get 40% and add it, or you could say it's 1.4, 140%. Because percent means over 100, if you remember, right? Okay, so let's get back to the problem. So 15% of 100,000 is 15,000. And if we subtract it off here, we get 85,000. So again, we could have done that straight up with this, because 0.85 of, and of means multiplication, of 100,000 is 85,000. All right? So we figured out the bonus, right, without knowing the salary yet. We don't know Joe's salary yet. We just know his total net income. And his total net income was based on his salary, his bonus, and his raise. Okay? So we figured it out because they're telling us the bonus is 15% of whatever he ended up with. Not what he started with, whatever he ended up with. Which means his actual bonus, based on his original salary, was some other percent that wasn't 15%. Okay, because maybe they gave every employee $15,000, and it just so happened that it turned out on Joe's salary and raise that it turned out to be 15%. But on mine it may have been 20, and yours it may have been 10, and so on and so on. All right, we don't care. We're just trying to understand the word problem. And by the way, that's why I worded it this way, and that's why I did it this way. So even though it's not standard, that's what these problems are about, especially in grade 9. You have to think them through and ask, what is the test writer really asking me to do? What's the point of what the thing is here? It's a simple enough problem. There's two numbers there, and you just need to figure them out. So let's back off this part now that we know what the bonus is. Okay, the bonus was 15,000, and he ends up with 85,000. So here we have his salary plus the bonus plus his raise equals $100,000, right? We now know his bonus was 15,000, giving him 85,000. So we can add it in here. Plus his raise equals 100,000. And if we subtract it out, we're just chasing tails. So we get 85,000. His salary plus whatever he got in his raise is 85,000. Okay? We know his raise was 15%. So if we do salary plus 15 equals 85,000. That has no meaning. That's meaningless. So it's 15% of what? It turns out his raise is 15% of his salary. So it's his salary plus 15% of his salary equals 85,000. Okay? So if we use the distributive property, and some of you probably know where I'm heading here, but this is basically S1 plus 15% equals 85,000. Right? So 1 plus 15, this is 100 over 100, and this is 15 over 100. So we get 115 over 100, or S times 1.15 equals 85,000. And this is similar to the discussion we had up here about doing things with percentages. Okay? So this is not the normal form. We would just say 1.15 S equals 85,000. All right? So it means to get the salary, we need to get the 85,000 divided by the 1.15. All right? So here we have a super ugly problem that you have to get right. So this kind of question would probably be a grid-in problem. All right? And let me just make sure we're still live. Yeah, we are. Okay. And instead of computing that live, let me just show you what the answer is, and you could compute this yourself. You're going to get the salary equals, once you do that division, where do I have that? 73913.0435. Okay, this is his salary though. So if it was, say, a grid-in problem, and I'm assuming it probably would be more likely that it was instead of an ABCD problem, but the nature of the beast of this problem is not only was the question bad, but the calculations in the problem are bad. And remember that normal arithmetic is a lot of what kills a lot of kids on the SHSAT, and a lot of standardized tests for that matter. So that if you don't do the divisions right and so on, you're going to get screwed. So if you don't get this right, then you have the wrong answer. So that's number one. The second thing is, this isn't what the question's asking you for. The question's asking you what is his net income will be from his raise. So we have to take the subtract the 85,000 off of that. Okay, and when we do that, we're going to get 11086.95652. Now, in giving all these decimal places over here, in the actual SHSAT, they're going to say something like to the nearest penny. Okay? In this case, I didn't state that. So since we're dealing with dollars and cents, unless you're on something like the stock exchange, we are going to, just by default, go to the nearest penny. You would have probably rounded this original number here, which means you would have thrown these two away, which means you probably would have thrown this away, and you would have ended up with something like this. Okay? The SHSAT may also say to the nearest dollar. So be aware of that, so that when you get this number here, you can round this and throw the whole thing away and just be left with the 73913. Okay? And subtract that from the 85,000, which means you'd be throwing this away as well. In fact, this may end up being a 7 at that point, if I'm not mistaken. All right? So you'd actually have to do the actual subtractions to find out what you're being asked to do. So here we have a really trivial question that's super nasty, and you just have to go through the ugly math to get to it. And this is one of those ones where you may have to do it 2 or 3 times to get the right number, and unless they give you multiple choice, you won't know you're doing it wrong. So that's the killer of this. Now, in the real SHSAT, the numbers won't be as ugly as this. I kind of did this on purpose to kind of emphasize the issue. What they'll do is they'll put nice numbers here and work the problem backwards so that they won't start out with $100,000. They may start out with, say, $93,786.54, just so that the 15% and all of this stuff works out. All right? So in this way, that's easy enough for a test writer to do. So that you're not just spending 15 minutes doing ugly long division and stuff like that. So they'll do that for you. I didn't do it in this case. That said, there are some tests where they really want to push you. It's not going to be the SHSAT. Normally when you kind of sit back on the SHSAT and observe it, there's normally a way that the numbers work out in a good way to your advantage. So always keep that in the back of your mind once you run into problems with some of these. Normally you can run a simplification of some sort. In this example, that wasn't the case. But if I gave you different numbers, it may have been. Because instead of like 85,000 divided by 1.15, it could have been 115,000. So your division, instead of being 79,000, maybe 100,000 or something like that, or 10,000, whatever it turns out to be, where you have a nice clean number at that point. All right? Okay. We're going half an hour. I'm going to keep pounding away on these. There's a lot of different YouTubes I want to do for you guys. Again, please like, please subscribe, and peace out.